high concentration NH4 through to the sea.
Well, thank you very much. We have to move to the last presentation of our session. May I invite Ahmed Dalban for this presentation. The title of the presentation is Towards Zero Emission Concept, Utilization of Palm Oil Mills Fly Ash for Treatment Different Industrial Wastes.
Good morning, everyone, and thank you, Chairman, for your introduction. My talk today will be about Towards Zero Emission Concept, Utilization of Palm Oil Mills Fly Ash for Treatment Different Industrial Waste. In this time, we'll focus about only one different waste, which is palm oil effluent. Background about palm oil industry in Malaysia. You know, in Malaysia, a huge amount of palm oil is produced, and also not only in Malaysia, Indonesia also, and some other countries. This is the main business for them. With this industry, huge amount of waste coming as a solid and also as a liquid. Solid waste will be utilized usually as fuel after drying, and no need for energy to use from outside. So we use this waste, solid waste, as fuel in the boiler to get the oil. Liquid waste, if you produce 1 ton of, for example, oil, you need 4 tons of water, because huge amount of water is being used. So huge amount of waste actually there. Bringing this waste to produce energy usually accompanied by producing huge amount of waste fuel, and in this case, this waste or fly ash from this waste we are trying to utilize, because big amount we need to not to throw, because there is limited places for throwing this waste. So how to utilize this? Usually, if you have, for example, 1 kg, 10% only will go as oil, and 90% will be waste. So you see, big amount. All this after treatment, we need only this one. So after this all will become a waste. This is the solid waste, and this one is the liquid waste. Objective of this research to produce inorganic coagulant from fly ash to treat palm oil mill effluent or POME to be used in the real fields where POME is produced, and to utilize solidified waste after treatment as fertilizer in palm oil farm, since the waste contain high nutrients such as potassium, phosphorus, potassium, nitrogen, magnesium, and calcium. And to use the produced inorganic coagulant for treatment aquacultural bone, I will show you a model of this one in aquarium. Fly ash samples were collected from 3 different places in Malaysia: Sungai Terang, Kelantan, Ulu Remis in Johor, Banjai Alam in Terengganu. And after sieving, we got 2 types. You see here black, and this is gray. Black means high carbon content. It means that temperature treatment is low. This one, high temperature treatment, became gray. So carbon will be less. Here you see this is the particle size diameter. We take only this distribution of particle size diameter. So no big difference between gray and black. It also lost on ignition, or VOCs, volatile organic carbon. Here you see in black is high content, 90.6 and 91. In gray, it is 14.5, meaning that almost carbon already evaporated. Here we did the test with the BOD, and we found that this is the original, and this is after treatment by fly ash. You see here, there is second day, first day, there is a significant reduce, but at the end, it is not a big difference. And this is 3 times dilution, so the value here about 4 multiplied by 3, about 12 ppm, which is somehow acceptable to be disposed in the open environment. This one for heavy metals, you see here different. I can show here much clearer. Here different types of heavy metals. We check the heavy metals removal for chromium, for copper, for lead, and for iron. You see a significant reduce, except for copper, which means that maybe this is leaching from the fly ash itself, and also for lead, maybe here also leaching from the fly ash. Here after treatment, you see here, this is the original here, and this is the original. This is 2 different types, gray and black. You see here after treatment, 1.5 became very yellowish, and significant reduction. So in this case, if you want to, how to say, to dispose the open environment somehow, okay. And also you can use it for biodiesel, for example. You can make like now they are using this waste like biodiesel source or biogas. Here what we expect that this is the effluent, which is huge amount. I told you before that if you have 1 metric ton of water or oil, you need 4 tons of water to be produced. So this is a huge amount of waste. Our idea is to make inorganic coagulant to add, and then after dewatering, this after solidification by filter press or whatever, then this can be utilized as fertilizer in the palm oil, because it's high nutrition for potassium, magnesium, calcium, and other sources. Application in aquaculture. If you have aquarium at your home, you will notice 2 main problems. One is the turbidity. The second one is awful smell. So at home, usually unpleasant smell you will notice. So what we are doing here, we try to use fly ash as cleaner. But if fish, sometimes, for example, any traces can eat, it's not toxic. We monitor for about 3 months. As you see here, by WHO 2030, aquaculture will be about 50% of protein coming from the sea. This will be through aquaculture. Means huge amount. This is the turbidity concept for those who are not chemicals. Maybe they can understand. This is low turbidity. This is high turbidity. This is from real farm in Malaysia. You see here, this is, I think, shrimp here. And you see there is little bit turbidity there. What is the effect of turbidity? You can see here, high turbidity here will give death for fish. But low also will make unpleasant stay for the fishes. For example, if you have, for example, 100 here, 100 NTU turbidity unit. In the first days, you will see fish start to show sign of stress. And if it is longer, will be more severe effect on fish. If longer, finally death. So how to remove this turbidity? We made the prototype, and this prototype is we add fly ash and then we monitor. And we try to make it fully automated. So we add 3 sensors. One is for turbidity, one for pH, and another one for temperature. As you see, this is our system here. So we make small chamber here for mixing. So this is the cleaner. When turbidity became here higher, pH sensor and turbidity sensor will send signal to your mobile. And from mobile, you can adjust this cleaner to open. And then automatic mixing. And then here it change between clean and turbid water. Finally, you will get very clean water. But all automated. For people who are traveling, this is very good things to be fully automated. But for people who are staying, who want to enjoy, you know, aquarium life, we made it also semi-automatic. So you can also control by your own. We make comparison between our system and another system. What is available now in America, there is one very good system actually, but the cost is a little bit high, about $500 US. In our case, it is about 500 ringgit Malaysia. It means 1/4. So big difference in the cost. Here I want to show you a video about how it works. So our aim is stress reduction. This is for benefit for human when see this kind of thing. Disadvantage, of course, turbidity and bad smell, as you all know. Time also for feeding and cleaning. So our system, we suppose that can solve the problem. We call it autonomous aqua care. So we monitor through our hand phone and pH sensor, turbidity sensor, and also temperature. We send the signal and store in iCloud, and then go to your mobile phone. Once turbidity reaches certain level, we'll give you a warning. So this is from fly ash. This is the first day. You see here turbidity became higher and higher. So we have estimated also the cost. It is about 100 gram, about 10 ringgit. 10 ringgit for people who are buying our system, and 20 ringgit for the people who are not using our system. So in this technology, we try to combine chemistry, biology, and also IoT, Internet, what do you call it, IoT? Internet of Things. Thank you very much.